Okay, so welcome back. So now what we're going to do is we're going to talk about, hey, we're going to figure out when does a geometric series converge and when does it diverge. So let's look at a geometric series. So in the general case, so we have this, and let's assume that A is positive. So the initial term is positive. And so the sequence of partial sums is given by this expression here. Okay? So now let's consider the case when R, so we haven't dealt with this here, so we're assuming that A is positive. Let's say what happens when R is 1. So let's consider the case that R equals 1. Well, if R is equal to 1, what happens to S sub k? Well, then S sub k, all the R values become 1, because 1 to any power is still 1. So we get A plus A times 1 plus A times 1 squared, and so on. And so, what do we have here? Well, we end up just having A times A, K times, right? So we get A times K. So the partial sum, when R is equal to 1, the partial sum becomes A times K, which is divergent, right? So the sequence diverges because it's obvious as K goes to infinity, right? As K goes to infinity, the partial sum goes off to infinity. Therefore, the sequence of partial sums diverges, which then we conclude that the series, the geometric series, when R equals 1, is divergent or diverges, okay? Now, and again, this is because we can't forget that it's one of the things is that A is positive, right? So when A is positive, obviously this is going to go off to positive infinity, okay? Okay, so now what happens when R is not equal to 1? Okay, well, let's consider that. Okay, so let's consider when R is not equal to 1. So now what I want to do is let's take the partial sum here, the expression for the partial sum, and let's multiply both sides by 1 minus R. You might be wondering why I do that. You'll see. Okay, so now if I multiply both sides by 1 minus R, I get 1 minus R times S sub k, which is then equal to 1 minus R times the summation from n equals 1 to k of A times R to the n minus 1, which is then going to be not n minus 1, 1 minus R. 1 minus R times A plus AR plus AR squared plus all the way up to AR to the K minus 1. Okay, now, there's a common factor of A here in this expansion of the series, or a partial sum. So now, if I factor out the A, I get A times 1 minus R times 1 plus r squared plus r cubed all the way up to r to the k minus 1 power. Now, if I distribute this, what happens? I get a times, so 1, distribute 1, I just get this whole thing. So I get 1, how do I want to do this? Let's put this all in brackets. So I get 1 plus r squared plus r cubed all the way to plus r to the k minus 1, right? But then I'm going to subtract all of the same terms multiplied by r, right? So I'm going to have a subtraction sign. These are all going to become subtract. So I'm just going to factor out the minus, the subtraction, and then this is going to be minus what? Minus the quantity r plus r squared plus r cubed plus r to the 4th all the way to now r to the kth power. Okay? Now notice here that because I'm subtracting this whole thing, all of these are going to become subtractions, and so I get r minus r squared minus r squared all the way through r to the k minus 1, because there's a k minus 1 in here as well. So all of these terms cancel with all of these terms, and so what we end up with, let's put the bracket here. So what we end up with is a times 1 minus r to the kth term. Okay, now, what do we get now? Well, this is equal to this, right? So what we just did was we multiplied everything by r minus, 1 minus r. And so this, we found, is equal to this. So if we divide everything by 1 minus r, then we're going to get s sub k, right? So then we get that s sub k then is equal to what? It's going to equal the sum or no, hold on. No, because, okay, I'm sorry. This is equal to this. So this s sub k is equal to this. So s sub k then is going to equal this. So it's going to be a times 1 minus r to the kth power over 1 minus r. Okay. So this becomes our formula for the kth partial sum. And this is for when r is not equal to 1. Okay, now, what happens to this thing? So again, from the previous discussion that we had, we know that the geometric sequence r to the k approaches 0, right? So again, we're talking about geometric sequences now. Okay, so what happens to geometric sequences? Okay, when r to the k approaches 0. So if we look at geometric sequences, so let's go back to our discussion of geometric sequences, r to the k, right? So we know that r to the k approaches 0 when the absolute value of r is what? Less than 1. Okay? And that r to the k diverges when what? The absolute value of r is what? Well, greater than or equal to 1, right? Okay, so that was based on geometric sequences. And so since we've got this as the representation of our partial sum, which is again, we're dealing with a sequence of partial sums now. Okay? So now, what happens here? How can we split that up? Here. So if we look at r to the k and we use this factor, this approaches 0 when the absolute value of r is less than 1. So what can this tell us? Well, that tells us that in this case, if in the case that r, so if the absolute value of r is less than 1, then we know that as k goes to infinity, right? So as k goes to infinity, so k goes off to infinity, we know that r to the k is going to go to the 0, so s sub k then is going to approach a times 1 minus 0, so this is just going to be a times 1, which is a. So this is going to give us the partial sum is going to approach a over 1 plus r. Okay, so what does that mean? Well, it means that the partial sequence of partial sums converges to that expression of a divided by 1 minus r. And so now what we know is the series then, right? So the series so this means in the case that the absolute value of r is less than or equal to 1, the series for n equals 1 to infinity of a times r to the n minus 1 equals what? It's convergent, and it equals a over 1 plus r. Okay? Now, that also tells us if the absolute value of r is greater than or equal to 1, right? If the absolute value of r is greater than or equal to 1, then S of k diverges, because this is a divergent. This diverges, which means the whole thing is going to diverge. And therefore the series diverges. So that tells us that in the case that the absolute value of r is greater than or equal to 1, then the series n equals 1, the geometric series, diverges. And that's it. So next we'll start with the definition.